All right, guys, lesson 1.5, radicals and rational exponents, and how these two connect to each other. This is going to be a pretty quick lesson today. I know I've said that before, and it doesn't always go quick, but this one, there's a couple of ideas that are basic, fundamental ideas, but I need you to understand them for things that we're going to do in the future. So, before we even look at the textbook, there are a couple of things I want you to put in your notebook, all right? So let me add a little sticky note here. And what I want you to do is I would like you to add the stuff I put in this sticky note. I want you to add it to your notebook, all right? So as we go through this lesson, the textbook assumes that you remember some stuff from last year, and I don't know if you remember that or not. So a couple of things that I want to address. First of all, a radical. If you remember what a radical is, that is something like the square root of x or the square root of 4. That's a radical, okay? Anytime you have a square root, you're dealing with a radical. A rational exponent is when your exponent is a rational number. And if you remember, a rational number means you can write it as a fraction. So like x equals 1/2, or 4 to the 1/3 power, or -6 to the 7/2 power. All right, so today we're going to connect these two things together. All right, first thing that I need you to remember, if I were to give you a problem like the 4th root of 64, if I wanted you to solve this problem, the way that you learned how to do this last year is you would take 64 and you would break that down. That's 32 multiplied by 2. 32 is 16 multiplied by 2. 16 is 8 multiplied by 2. 8 is 4 multiplied by 2. And 4 is 2 multiplied by 2. So when I break this down, I have 1, 2, 3, 4, 5, 6 2s. So I can rewrite this as the 4th root of 2 times 2 times 2 times 2 times 2 times 2. And what this 4 on the outside means is if I have 4 of the same number on the inside, I can pull those numbers out and move them in front. And when I do, it becomes a 2. I pull out all 4, but when I pull them out, they turn into 1. And I'm still left over with a 2 times 2 on the inside, which this simplifies to 2 4th roots of 4. It assumes that you remember that, okay? If I want to take the cube root of negative, 81. Negative 81 is going to be a negative 9 times a positive 9. Negative 9 is going to be a negative 3 times a positive 3. 9 is going to be a positive times a positive. So I end up with these numbers on the inside. So I get the cube root of negative 3 times 3 times 3 times 3. And I've got one negative 3, but I have 3 positive 3s. So I can pull those out. And this becomes 3 cube roots of negative 3. All right, are we okay so far? Hopefully, most of that is review information. The other things that I want you to add to, let's make another sticky note over here because I don't want to write over the top of this one. The other thing that I want you to remember from last year, and I really, really hope you actually were taught this last year, is if I have the cube root of the cube root of x. Actually, you know what? Let's say the cube root of x to the 4th power. That is the same thing as the cube root of x. And if I put the 4th power on the outside, those two mean the same thing. Okay, just different textbooks use it different ways. It doesn't matter if the 4 is with the x on the inside or if it's on the outside. What does matter is when I can rewrite this, and instead of a radical, I can take that 3 and I can put it on the bottom of a fraction and I can keep the 4 on the top. So my exponent stays on the top. The 3 from the outside of the radical moves to the bottom of my fraction, and I leave it like that. So if I were to have the 7th root of 2 to the 3rd power, that would become 2 to the 3/7 power. Now, what's nice about this year is you can plug that into your calculator. I'll show you how in class. You can plug this into your calculator. Most of these problems you're going to be able to plug, when it wants a value, you're going to be able to plug it into your calculator and get a value. The problem is, what happens when it just gives you x's and y values and wants you to work with x's and y's? You have to understand these rules so that you can manipulate problems when you can't just put a number in a calculator. Because if I had, what is the, square root's too easy. What's the 3rd root of x to the 7th power multiplied by 8 multiplied by y to the 4th power? I have to know that these 7 x's make 2 groups of 6, and those 2 groups are going to come out. I have to know that this 8 is going to be 3 2s, so those 3 2s are going to come out. And of these 4 y's, 3 of them are going to come out and turn into 1, and I'm going to be left over with x to the 1st power. And all of this is going to be on the outside. I can't just plug that into my calculator and get an answer. It doesn't work, okay? So you need to understand and remember these rules so that you can use them. Okay, going on to the new things in this homework that you're going to see. This word right here, nth roots, okay? Nth roots, it's kind of like if I were to say, what is the square root of 4? Well, the answer is 2. That is an nth root of 4. Well, that's not an nth root. That's a second root of 4. That's a square root of 4, right? So maybe let's rewrite. We don't want nth. We want, that is the square root of 4. That's how we would say that. If I wanted to know if I did 4 roots of 81, my answer would be 3, because that is one of the 4th roots of 81. Okay, 3 is one of the 4th roots of 81. Now, here's what I need you to know about this year, okay? I don't expect you to memorize this chart down here below. There are a couple of key things here that aren't too bad to know, but I don't really expect you to memorize them. Couple of things I do need you to memorize, all right? And we're going to put them right here on this sticky note. Actually, let's make our sticky note a lot bigger. So in your notes, I want you to put this. Your entire life, you have been told that the square root of 4 is equal to 2. That is true, but that is not the only square root of 4, okay? It's a square root of 4 because 2 multiplied by 2 equals 4. But there is another square root of 4 because negative 2 multiplied by negative 2 is also equal to 4. So when I ask you what is the square root of 4, this year in this class, there are 2 answers. We don't always care about both of the answers, but there's actually 2 answers to that question. You would say that the square root of 4 is a positive 2, and it's also a negative 2. It can be both of those, okay? The square root of 9 is a positive 3, but it's also a negative 3. And now here's where we need to be a little bit careful. And this is what these rules that I just covered up are explaining to us. Sometimes these numbers don't exist, okay? Like, for example, the square root of negative 4, there is nothing that can be multiplied by itself to get a negative number, right? Because negative 2 times negative 2 is positive 4. A negative times a negative is a positive. A positive 2 multiplied by a positive 2 is also a positive 4. So if I'm taking the square root of a negative, there is no real solution. There is a solution. We're going to actually talk about it later this year, but it's not a real one. It's an imaginary solution. So we have to be careful when we're taking roots because sometimes you can't. Sometimes there's not going to be a solution, and sometimes there's going to be more than one. All right? And that's what this little diagram right here is explaining to us. So what it's saying right here is if I have a if I have a exponent. Now, n is going to be our exponent, and a is going to be the number at the bottom. A is going to be the base. I should use proper math language. So if n is odd, if that number up there is an odd number, then a has one real root. Okay, so if I had something like, if I had, or I guess we should be writing this the other way. N is on the outside and A is on the inside. So if N is an odd number, so let's say N is 3 and on the inside I have an 8. The only answer to that is 2. There is only one root. Negative 2 doesn't work because negative 2 times negative 2 times negative 2 is negative 8. But I don't want negative 8, I want positive 8. So if the number on the outside is an odd number, you only have the positive answer or the negative answer. I guess would be true too, because the cube root of negative 8 is negative 2 times negative 2 times negative 2, which is negative 8. But I can't do regular 2 because 2 times 2 times 2 is positive 8. So it doesn't matter what's on the inside. If the outside is odd, there's only one answer, okay? If the outside is even, let's say the outside is a 4 and on the inside I have a positive number, then I have two answers. Okay, I'm going to have two answers. I'm going to have a positive answer and a negative answer. If the inside is negative, like this, then I'm going to have no answers. Isn't that kind of weird? If the outside is even and the inside is negative, there's no answers. But if the outside is odd and the inside is negative, there's one answer. Now, you don't have to memorize this because you can do these on your calculator, all right? For example, A right here. Find the indicated real root. It wants n to be 3, and it wants negative 27 on the inside. If you can't memorize those rules, plug it in your calculator, and you're going to get the answer negative 3. Cool, you're done. Part B, if n is 4 and A is 16, plug that in your calculator, and you're going to get the answer 2. But I need you to remember, if this is an even number, then I'm going to get two answers, a positive and a negative 2. I need you guys to remember that one. Your calculator is not going to tell you that. I need you to remember that one, all right? So down here, numbers 1 and 2, go ahead, try those on your own really quick. Pause the video, find your calculator, plug them in, make sure you get the right answer. Okay, so you should have tried the cube root of negative 125, and your answer would have been negative 125. Okay, or not negative 125. Wow, Mr. Reed. Negative 5. Negative 5 times negative 5 times negative 5. If the answer in here is a negative, underneath is a negative, you can't have two answers. You can only have one, all right? Or none, but 2 is definitely not going to happen. Number 2, if n is 6 and 64 is on the inside, this is even. So when I put this in my calculator is going to tell me the answer is 2. But there is another answer, a positive 2 and a negative 2. Both of those work, all right? If you don't believe me, do negative 2 times itself. Well, multiply 6 negative 2's together, you're going to get positive 64. Okay, evaluating expressions. Again, I need you to know the rules, but I don't expect you to use them on the problems with numbers in them. The cube root of negative 8. We just reminded you that you learned that you're supposed to do the cube root of negative 8 is negative 2 times 2 times 2 times 2. Well, there's 3 2's. Those are going to move to the outside. So I'm going to get 2 cube roots, and I'm left with a -2 on the inside. Oh, I multiplied too many 2's together. Mr. Reed, see, this is what happens when I record a video on a Saturday. -8 becomes -2 times -2 times -2, which comes outside. All 3 of those come outside, and I get a -2 as my answer. Part B, the negative cube root of 8. Now, that negative is floating in front. It has nothing to do with what's on the inside. So, if I want the 8 to break up, I'm going to get the negative cube root of 2 times 2 times 2. There's 3 of them. They're going to come outside, and I'm going to end up with the same answer, -2. Cool. C is 16 to the 1/4. You know what? Let's just do that right over here. This is part C. So 16 to the 1/4 is the same thing as the 4 goes out front, the 16 stays on the inside. Simple, simple. 16 breaks up into 2 times 2 times 2 times 2. Okay, maybe I should do that slow because this is an example. 8 times 2 is 16. 8 is 4 times 2. 4 is 2 times 2. So I have 1, 2, 3, 4 2's. So the 4th root of 2 times 2 times 2 times 2, all 4 of those can come outside and they turn into one number 2. But I have one more answer, right? I have a positive and a -2 because my number on the inside was a positive, which takes us back to part B. We need to be careful because part B, we had a positive on the inside, right? But we're doing the cube root, so never mind. It can't be a negative. All right, so let's see. Part D. Part D says -16 to the 1/4. So -16 to the 1/4 can be rewritten as the 4th root of -16. Now, here's the problem, okay? 4 numbers cannot get multiplied and all be the same number and end up with a negative, because I either have a negative times a negative times a negative times a negative, which is going to be a positive, or I'm going to have a positive times a positive times a positive times a positive, which is going to come out to be a positive. So there are no solutions for that one. You plug it in your calculator, it's going to get mad at you. It's going to beep and holler and yell and call you bad names. So don't do that. Rational exponents. We already talked about this rule. It's just reminding you that you can rewrite these numbers back and forth. So if I have a to the m over n, that can be written as n to the nth root of a to the m. And it doesn't matter if the m is on the inside or the outside. I always put it on the inside. I always put it on the inside. I don't know if I've ever put it on the outside for any reason, because it's so much easier to work with when it's on the inside, okay? So example A, 16 to the 3/4, that is going to be the 4th root of 16 cubed. Now I know the book tells you to do 16 to the 1/3. I don't want to do that. Or 16 to the 1/4, right? It wants you to do 16 to the 1/4 and then write it. Here's what I want you to do. I want you to take this and I want you to rewrite it this way. Then I want you to plug it in your calculator. If you can rewrite it like this, you can plug it in your calculator and get the answer. But I want to see this step. I need to see you rewrite it in this form, okay? Example B, 27 to the 4/3, I want to see you rewrite that as the cube root of 27 to the 4th. Then I will give you full credit after you plug that into your calculator and get an answer. But I need to see that first, okay? All right. So evaluate 3, 4, 5, and 6. Go ahead and try those really quick. I know the video's starting to get long. I promised you it wouldn't. And here I am breaking promises. It's Saturday. I'm here, so I feel like I should make you suffer too. plug these in your calculator after you rewrite them. If they can be rewritten, like this one and this one and this one, I will give you full credit after you plug it in your calculator. Come back when you're done. All right, guys, so number 3 doesn't get rewritten because it's already the cube root of negative 125. You plug that in your calculator and your answer should have been negative 5. I feel like we already did that problem. Maybe that was an example I gave you. Negative 64 to the 2/3. If you wrote the cube root of negative 64 squared, hopefully you put that negative 64 in parentheses, and then you got the answer of, what is that going to be? Positive 2? Yep, positive 2. If you wrote that, I will give you full points, but not if you skipped that middle step. If you just plugged it in the calculator, I'm not going to give you credit for that one, okay? I need you to do the full problem, and then I will give you credit. Or I need you to write the full problem first. Okay, 9 to the 5/2 power can be rewritten as 9 to the 5th, and in the front, I have a square root. You don't have to write the 2 if it's just a square root. Then you can plug it in your calculator and get an answer. Number 6, you should have written before your calculator work, you should have written the 4th root of 256 to the 3rd power. And then I'll give you full credit. Okay, moving on. Real life problems. You know what? Let's go through these really quick. There'll be plenty of you to try on your own on the homework. It says the radius of this sphere, this great big rolling squishy ball, is given by an equation. Well, that's nice. They give us an equation. I don't have to come up with one. V is the volume. The radius is R. And it wants us to use 3.14 for the variable pi. All right. What it wants me to do is find the radius. It wants me to know what the radius is. So I am looking for radius. R equals question mark. Guys, I make my calculus kids write that at the beginning of every story problem. What are you finding? Follow it with a question mark. So let's rewrite this equation. R equals 3, and instead of V, doesn't it give me a value? Oh yeah, in the picture. Oh, cool. I like that it's using the picture to give me information. So V, nope, that's not where my parenthesis is. V is 113, and that's going to go on the top of the fraction. On the bottom of the fraction, I have a 4, and it told me to use 3.14 for pi. And then on the outside of the fraction is a 1/3. Now, folks, if you make your calculator look exactly like this, you're going to get full credit, okay? If you write this equation on your paper, right here, and then you just plug it in your calculator, hit enter, and you get an answer, I'm going to give you full points on that question, all right? If you skip that step of writing the equation, if I don't know what you plugged in the calculator, you're not going to get credit for that question, okay? All right, I don't even remember what the answer is. What is it? 3. Da-da-da. Well, approximately 3. Do you know why it's saying approximately? I love that it doesn't say equals. I love that it says that little wavy equal sign. Because we used 3.14 instead of actual pi, so our answer isn't exactly 3. It's kind of 3, but it's not exactly 3 because we didn't use exactly pi. So I love that the book uses that, that symbol there. Okay, another story problem. It gives me in the inflation rate. Wow, that talk about being valid with the news today. You guys have been hearing about this like crazy. It gives us a formula for inflation, and it wants you to plug in some values. Here's what I would like you to do. I don't care if you use this formula. I don't care if you plug the numbers into your calculator and get the answer, but I need to see what you plugged in the calculator. So I want to see you say R is equal to, let's see, F goes on top, and F is it goes from P to F. So F is the new value. So F is going to be the 235,000. Wow. And P is the old value. That's going to be 200,000. And then on top, I have a fraction of 1 over n. And n represents 5, which is the number of years. And then I have this minus 1. All right, folks, you plug this into your calculator, you're going to get the right answer. You will get credit for that answer. I know I'm saying this a lot. If you want credit for that answer, I need to see the equation written on your paper. All right, I'm going to hound you on that all year long. We're going to get in the habit now. I don't mind you using your calculator, but I need to know that you used your calculator to get the answer. Something else didn't use your calculator to get the answer, like Mathway or Jeremy, because he's really good at math. All right, homework. 1.5 exercises are 3 through 17 odd, 19 through 22, 23 through 41 odd, 42, 45, 46, 47, 48, 51, 52, 53, 54, 55, 56, and those are all starred. I know it looks like a long homework, guys. Almost all of this is calculator work. All you have to do is write on your paper what you plugged in your calculator, plug it in, hit enter, write down the answers. Good luck.